are very popular drinks that are mainly composed of carbonated water, sugar, and flavors. Nearly 200 countries enjoy a sweet effervescent soda with an annual consumption of over 34 billion gallons. Soft drinks are considered the most popular beverage segment in America. Materials used. Carbonated water makes up 94% of soft drinks. Carbon dioxide gives the drink a special tickling and bite, and also acts as a mild preservative. Carbon dioxide is a unique gas suitable for soft drinks because it is inert, non-toxic, relatively inexpensive, and easy to liquefy. The second main ingredient is sugar, which makes up to 7 to 12% of soft drinks. Used in dry or liquid form, sugar adds sweetness and density to drinks and enhances the taste in the mouth, an important component in consumer enjoyment of soft drinks, of course. Sugar also balances the taste and sourness. Sugar-free soft drinks emerged from a sugar shortage during World War II. Soft drink manufacturers turned to high-intensity sweeteners, especially saccharin, which was discontinued in the 1970s when it was identified as a potential carcinogen. Other sugar substitutes were introduced more successfully, most notably aspartame, or NutraSweet, which were widely used in diet soft drinks in the 1980s and 1990s. Because some high-intensity sweeteners do not provide the desired mouthfeel and sweet aftertaste, they're often combined with sugar and other sweeteners and flavorings to enhance the drinks. The overall taste of soft drinks depends on a complex balance of sweet, sour, and sour. Tamarind adds a nutty flavor to the background of tastes and enhances the sensation of quenching thirst by stimulating saliva. The most common acid in soft drinks is citric acid, which tastes like lemon. The acid also lowers the pH, preserving the drink slightly. Other additives in very small quantities improve the taste, mouthfeel, aroma, and appearance of the drink. There are many scent options too. They can be natural, identical to nature, or artificial. Emulsions are added to soft drinks primarily to enhance the optical eye by acting as an opacity agent. Saponins increase the foam head of some soft drinks such as cream soda and ginger ale. Preservatives are added to soft drinks to inhibit the growth of microorganisms and prevent their deterioration. Antioxidants like BHA and ascorbic acid preserve color and taste. In the early 1980s, in response to increasing public health concerns, soft drink manufacturers turned to natural additives. Manufacturing of soft drinks. The production of soft drinks is a multi-step process and involves several steps before reaching the consumer. Most soft drinks go through a similar life cycle, from the syrup producer through the bottling plant to the distributor to the retailer and finally to the final consumer. Each component is as important as the other to ensure CSD is properly manufactured and packaged. Let's look into the details of how the manufacturing of soft drinks starts and reaches you. As it's a soft drink, water becomes the most important ingredient, so workers must pay attention to it. The quality of the water makes for a great drink. Water contains various types of impurities, microbes, organic matter, and airborne particles which can affect the color and taste of the drink. The traditional technical approach is to remove all these impurities, which involves sequential coagulation, filtration, and chlorination of the water. The coagulation process involves mixing into the water a precipitated flaky gelatinous substance. All suspended matter in the water is absorbed by the floc and consequently increases in size. The filter catches it easily. To remove fine shale particles, water is poured through a sand filter. Water is sterilized to remove microbes that can affect the color and taste of the water. Water is collected in a tank and treated with chlorine. After some time, the reaction gets completed. The water is then dechlorinated using an activated carbon filter. This removes all organic residues. Before the water is fed to the dosing station, the water is de-aerated with a vacuum pump. Now, it's time to mix the ingredients. Depending on compatibility, the dosing station is filled with aroma concentrates and dissolved sugars in a series of presets. All materials are then transferred to the batch tank. There, these ingredients are carefully mixed under controlled conditions. Movement is kept under control, otherwise it'll cause unwanted ventilation. Flash pasteurization, or UV radiation, is used to sterilize syrup stored in tanks. Some proportions carefully combine the syrup and water, which also regulates the proportions of the liquid. To avoid aeration of the mixture, carbon dioxide is pressurized in the vessel. This process is called carbonation. Carbonation is the process of adding carbon dioxide to a liquid, also known as fizzing. This always happens under very high pressure. When the pressure is reduced, carbon dioxide is released from the drink. This creates bubbles in the liquid. It makes sparkling water. The temperature of the liquid must be kept under controlled conditions too. Today's carbonators are equipped with an automatic cooling system. Now, the drink is made, but it's the packaging that attracts you. Let's see how it's done. Packaging of soft drinks. You must have seen that soft drinks are packaged in glass or plastic bottles, lead-free aluminum or plastic cans. Did you know sales of soft drinks began with the use of ice coolers in the early 20th century? Currently, most beverages are chilled by electric refrigerators for on-site consumption. Vending machines dispense soft drinks in cups, cans, or bottles, and restaurants, bars, and hotels use dispensing guns for high-volume jobs. There are two methods of selling soft drinks by the glass. With the premix system, the finished drink is prepared by the soft drink manufacturer and filled into 5 or 10-gallon stainless steel tanks. The drunk tank is attached to the vending machine where the drink is cooled and dispensed. With a post-mix system, the engine has its supply of water and carbon dioxide. Carbonated water as needed and mixed with flavored syrup when poured into glasses. This is how soft drinks are made. But what about quality control? Quality control. Soft drink manufacturers adhere to strict water quality standards: alkalinity, chlorides, sulfates, iron, and aluminum. Not only for the benefit of public health, but clean water also facilitates the production process and maintains the consistency of taste, color, and body. Microbiology and other tests are performed regularly. The National Soft Drink Association and other agencies set standards to govern the quality of sugar and other ingredients. When soft drinks are made with low levels of sugar, the particles in the drink spoil it and form flakes. To prevent spoilage, sugar must be handled with care in a clean, dry environment. Soft drink manufacturers need to check raw ingredients before mixing them with other ingredients, because preservatives may not kill all bacteria. All containers, pumps, and tanks are thoroughly sterilized and continuously monitored. Made of aluminum alloy or tin-plated low-carbon steel, the cans are painted internally to seal the metal and prevent corrosion when in contact with the drink. Regular consumption of soft drinks can be harmful. We saw how soft drinks are made, but it's important for you to know there is proof that soft drinks can harm your bodies. Yes, it's true. Regular consumption of soft drinks has been linked to various chronic health conditions. This increased risk is largely due to the added ingredients in soft drinks, especially sugar. Some sugar-sweetened soft drinks contain 40 grams or more of sugar per 12-ounce serving, which exceeds the daily recommended sugar intake for adults. Consuming just 1 to 2 servings of sugar-sweetened soft drinks per day significantly increases the risk of metabolic syndrome and type 2 diabetes. In addition, both men and women who drink sugar-sweetened beverages have an increased risk of coronary heart disease